Hello everyone, it's Sean. Welcome back to the channel. What I have in front of me is a Lafayette Airmaster 10 transistor based radio. It's a rather unique radio. Now, when transistor radios came out, they typically did some tricky things to get the transistor count up. This one claims to have 10 transistors. It's a radio built circa 1968 approximately, at least from what's annotated on Radio Museum. Typical AM super heterodyne receiver, as well as if you look at this little section here on the left, you'll see a megahertz section from 108 to 135 megahertz. This appropriately labeled aircraft would be the VHF or very high frequency range used in commercial aircraft. So you could be receive commercial aircraft receptions from line of sight radios at airports, etc. Predominantly VHF used by commercial aircraft. UHF range would be more military aircraft. But this was lying around the office, and this Airmaster 10 does not power up. And I was like, oh, hey, I'll take it home and we'll take it apart, see if we can get it working, look over it. So that's what we're going to do. I suppose the first thing I could do is try to get this powered up. We'll plug it into, have it plugged into a dim bulb tester. Okay. So this is currently sitting in here. It's currently in AM. And we'll do just like that. I'll put the volume around mid-range. There's a little volume control knob here. I feel it click. You can hear it. Yeah, it clicks, and we'll put it somewhere around mid-range. I don't know what the issue is going to be with this power supply. This kind of been hack jobbed into here or something else. But yeah, let's try powering it up. See if we got any immediate shorts. Oh, it's actually immediately powering up here. Lost power for a second. Here, let me turn off my filters and then we can play around with this together. I'm not seeing any shorts on the dim bulb tester, so that's good. Here we go. Yeah, so it seems like the power cord is kind of finicky. Switch it over to the VHF band. On the lower end, we're actually getting some radio stations.
For those things because it's factually untrue.
Interesting.
You guys can listen to. Maybe some of you agree. Maybe some of you think I'm a troglodyte, awful misogynist, racist.
Wonder what the IF is for this thing, at least on the AM side. Anyways, pretty cool receiver. Has some issues on the power supply side. I suppose we can address that and maybe get through an alignment with this video as well. So just a few screws for the back of our clamshell or case here comes off. There's a little door here which you can turn. It unlatches it to pop out. Used to be some kind of felt or something back here. That's all completely eroded away at this point. You can see styrofoam or whatever particulate still sitting here on the bench. That exposes a battery container that makes use of 4 AA batteries powering this radio via 6 volts. And it is corroded. All the terminals are completely corroded. Perhaps I'll get this into some vinegar and get that cleaned up, and then we can heat shrink it, and I'll just cut it out for now. That will be the easiest way of handling that. Our power connections here on the back, this one was already broken loose. That's why that cable is sitting there freely. Let's see, can I zoom in a bit? Here we go. Yeah. So, ooh, my filters aren't on. Hold on a second. There we go. Should be a bit better, less hysteria in the background. You can hear me. I do need a better mic because this one picks up on a high frequency when I pronounce S's. You can hear that high pitched tone in the back. Haven't quite figured out how to get that out. So if it comes across annoying, I do apologize. Bear with me until I get a better microphone. I went to a headset because my the mic I was using, I have a tendency to move away from it, and then it detects my voice less. Just makes it that much harder to edit videos. Anyways, I'm getting sidetracked. Here goes our 2 power connecting options through the back. You see both A and B sitting right there. The A side is what this power cord was plugged into right here. This little post, it actually popped out from this point right there, so that's why it was sitting loose. This guy was still inside the way it should have been, with a little, what used to be a gasket, rubber gasket that's now very, very hard, which means that it is brittle. So if I press on it, it's probably going to break in half. And then a little locking type. I wouldn't say a nut. It's more like a washer, a screw-in washer on the other side that holds that one in place. So that's part of the internals. Looking over the input of this, it appears our center pin might be negative and the outer pin is positive. Let's see, can we test that? Let me move this guy into here. Just do a quick continuity test. Okay. And let me see. Let's go to the center pin here. Center pin, and yeah, center pin is negative. That means that the outside is positive. There appears to be some kind of diode in there to support reverse polarity or something. I'm not too sure. That's why that beeps for a second. So what that means is that when I go to test this in volts DC, we'll come back out here. That center pin needs to go to the negative probe, and this one to the positive. Let me turn AC back on, and we'll check this. This power supply providing 6 volts, 75 milliamps, with an input voltage of 117.50 or 60 cycles. So here goes center pin. Yeah, we do have a issue with the connector here. You can see loose wire somewhere in here. That explains why it was not powering up. Oh, got it for a second. There we go. Yeah. Oh, there goes the 6 volts right there. 6.3 volts. There we go. Yeah, so the problem with the power exists right inside of this connector here, which is something we're going to need to address. Otherwise, the voltage coming out of this old power supply seems pretty steady. So, okay. Yeah. Let's power up the radio itself and poke around a bit. Well, it took me a while to find some schematics for it, but I think I've got some things figured out here. It appears that when we're in the AM position, T3, 4, 5 is for tuning the IF, T1, 2 for the IF of our VHF side, 3, 4, 5 of our AM frequency side. I've got my SIGGEN set for 455 kilocycles or kilohertz, 1 volt peak to peak, modulating frequency of 1 kHz at 90% AM depth. And we're just going to tweak a bit. Of course, the switch in AM. Now that that's a bit clearer, let's drop the voltage down from 1 volt peak to peak. Let's take it down to 500 millivolts. And let's take it down some more. Going to go to 100 millivolts. think our back end to that T6 and T7 is probably these guys right here. Let's see if we can pick them up. Well, the only one really having an effect, this one, is this one right here. Let me just go through a couple more just to verify. Okay. So I'm assuming, it's not seeing it on here, but our IF probably for VHF is going to be probably 10.7 megahertz. Let's see. Frequency 10.7 megahertz. We're going to start off again. Amplitude of, let's do 1 volt. And then again, so that back end. Oh, let's turn it into here. Here we go. Okay. Let's see. Alright, so these definitely have an effect for that 10.7. Alright, let's come to the front side. now we can drop this voltage down a bit. So let's take this down to an amplitude of 0.5 volts peak to peak, or 500 millivolts. Now I'm going to take it down to 100 millivolts. Hey, let's do, can we get any lower than 100 millivolts? Let's do 70. Worked out pretty well. Let's go from 70 down to 40 millivolts peak to peak. Okay. So with let's take it down to about 20 millivolts peak to peak. Let's see what we get there. Alright, so what I'm going to do now is use a little bit of, just a touch of isopropyl alcohol to take the Sharpie markings that I currently have off of on there. Get those off. Now I'm going to come through with the gold and mark the eyelets on each one where it's currently tuned to for that 10.7 megahertz IF. As a matter of fact, why don't we I'll zoom in using my microscope so you can see that. Let me get it turned on. Get this all the way up. Okay, we'll turn them. There we go. Alright, so that one was red, that one was red, that one was red. So blue here, you can see that eyelet right there in the top. A nice strong dot right there. Do another one right there. And that one's got some glue in the way. But we'll go to the opposite side. Well, hopefully I'll remember that in the future. Could always come back to the video. Let's see, what else do we got? Alright, here. Alright. That's going to take care of, let's see, 1, 2, 3, 4, 5. All 5 tuners. On the VHF side, I'm going to switch this back over to AM. Let me move this out of the way. Let's go back and change 455 kHz. And we're going to make sure that we're on point one more time on this side. Tuning of our IF out of the way, we now need to align the dial plate, for the lack of better terms. We're going to start on the AM side with a frequency of 600 kilocycles or kilohertz. Again, starting with an amplitude of 1 volt peak to peak. We're going to modulate it with a 1 kHz tone at a depth of 90%. Okay, so I'm taking this spool of wire that's connected to my SIGGEN, and I'm just going to kind of drape it somewhere. Yeah, there we go. That should work. And from the back, I've got to do some adjustments. Let's see. Are we on 600? Probably be better if I could get some things out of the way. Let's get this right on 600 is about right there. Okay. Again, let's get this close and let's see. Go. Let me drop that signal down some more. We're going to go from 1 volt to 500 millivolts. Okay. And I'll drop it down. Let's do 100 millivolts. Alright, I think that's pretty much gonna be it right there. From there, need to do the same thing. Let me turn the volume down a bit. We need to do the same thing, but we're going to go up to, still on the AM band, we're going to put the tuner around 1600 kilohertz or 1.6 megahertz. Okay. Yeah, so at the very far end of the scale there. And then this time I'm going to take the radio and flip it around. Okay, like so, and I'm just going to drape this again over here near the bar antenna. And then the last one was this guy down here for 600. That was the very bottom one. Let's figure out which one has an effect on our 16. Let's see, 1600 kilohertz. I'm going to start it with an amplitude of 1 volt peak to peak. We're going to turn on modulation and see if we can't find it. And I don't know, let's see. We'll just play around with each one till see if we get anything. So that's coming through around 1400 kilohertz. Let's see, does that take it off? No. Will this take it off? Yeah, that has no effect on either. So this is the one where we should be chasing. I'm going to take my amplitude even higher. Let's do 2 volts peak to peak. Well, it really doesn't seem to like that, so why don't we just do it at, let's see, 1400 kilohertz, and I'll take the dial, take it up to 1400. We'll see if we can get that one in. Alright, let's take our amplitude down again. And I think that's going to be about it for the AM side. Now, as far as the VHF side, my SIGGEN does not go, 108 to 135, whatever. I think this is only a 30 megahertz SIGGEN, so I don't get up nearly as high as I need to. Um, there's just nothing I can do about that until I can,
Rapid re-
unless I take it somewhere where I can get, where I have a better signal generator. I was looking at the front faceplate and figuring out why it was awful wibbly wobbly. It was being held on by scotch tape. Uh, I guess the glue had weared out. And it's obviously bowed. I'll remove the scotch tape from it. Let's see if we can kind of get this flattened out just a tad bit. What I'm about to do, some people will probably scream at me, but oh well. So the battery pack I had soaking in white vinegar for a while, about 30 minutes to an hour, just to neutralize any of the corrosion if it pertained to battery acid. It knocked off a bit of the corrosion and the rust as well, started to expose the copper underneath the I assume tin plating or whatever the plating is. And then I used some Barkeeper's Friend and lightly polished everything to get off the rest of the corrosion. So we're going to see if we got continuity from lead to pins. Let's see. Okay. So right here I should be in continuity on red. And I do. So if I go to the top side here of my plate right there. And if it'd probably be better if I strip these wires back just a tad bit. We're going to have to tin them up and solder them regardless. Let's see. Are they too small for this guy? Yeah, I can barely fit the wires through there. Okay. Let's use a bit of heat to remove the insulation off of it. Okay, there goes one. And two. Now our center conductor is exposed. Let's try this again. All right, So red wire that comes through, touches this part down here. There we go. Which means that it should also go up there, and it does. Okay. Let's see. Black wire goes to the bottom here. We got continuity all the way to the spring top here. So that's good. And let's see, what else? All right, so this spring right here should connect over to this point right here. Yep. And then this pad right here should connect over to this spring on this side. And this was a pad that was slightly more corroded. And so the spring, there's continuity, but the pad there is not. Let's see if we can. I wonder if that's an issue that we can resolve. With a bit of heat and solder. Probably not, but we're going to try either way. Okay, so I've got my soldering iron, whatever. Soldering iron. We'll set it to 750. And let's see if we can get any of my rosin core solder to tin that copper pad down in here. Definitely heated it up, started to melt the plastic. I don't want that. Let's turn the temp down just a smidge. Okay, I'm going to put some flux down in here. Okay, not really the most appropriate way of handling this, but let's see. We're still without continuity, it appears. Let's see, is there anything else I can use? I think I got something that I might just be able to replace this with. Wonder if I can just pull this one out and then feed that through and glue it down. That might work better. Yeah, let me snip this out. We'll just replace that entire pad right there. And I'll come back to this once I've got it all figured out and new parts put in. Okay, so I went ahead and replaced all these springs and points in here with spare kit I had. Put a bead of super glue down to hold them in place, but we've got full continuity between all 4 points, and I'm pretty sure if I put 4 batteries in here as per designed, we should be seeing 6 volts. Okay, and let's see if we actually get 6 volts. There you have it. 6.3. Cool. So what I'll do now, so I'll take one of these batteries out, this side and this side, and that should fully isolate the circuit. So release our radio, and let's get these items soldered back in their connectors right here. All right. Okay. We have battery power. So, with the battery pack out of the way, what I'm going to do now is work on and getting this power connector right here back into the back half of this clamshell. This little post right here is going to need to be pressed into this, and I'll probably use a touch of super glue to hold it in place. And then this little thing that I called power flag as well is actually not looking at the schematic. We have our power connection here, UM3 1.5 volt batteries times 4. Speaker, that appears to be an earphone connection, so we could put a headset up to this radio receiver and listen through a headset. But yeah, I'm going to get this kind of put back together as best as possible, then we'll go from there.
Yeah, so we're going to do a proper alignment now with this IFR SIGGEN. 108 megahertz. You can see the output RF level and dBm, 90% modulation, 1K hertz tone. And that 108 hertz tone is shown all the way up at the top, so need to readjust this. Okay, so got 130 megahertz shown up pretty much on the dial. I'm going to change this to 108. We'll see if it brings in at 108 as well. Alright, let's see if we get 108 as well. And we're a little above, but otherwise there, I think that's going to be good enough. There's some VHF communications from a local airport.
410,
See if we can get anything. Oh.
4,500, 4,200.
Of course, we're on the aircraft VHF band right now. Line of sight communications are a bit tricky. You have to have clear line of sight, really. 3 lines, buildings, other infrastructure will impact your line of sight communications.
Moderate light, the mic stop. The right side.
Looks like we got something around 135 megahertz too. Of course, the closest airport to me is a military base, about 30-minute drive up the road. And let's say more like 15, maybe 20-minute drive. And then from there, there's a regional airport. It's probably about 45 minutes up the road.
Learn more at oceansbiloxi.com.
It's a pretty hot radio. Let's go over to the AM band. Okay. Let's see if we get anything on the AM band here. I don't have the best AM reception out at my house. That popping could be because some electrical caps that might need to be replaced, or you know, all kinds of things create that kind of interference.
Vehicles can come around so they can park in the 2 private parking lots at $60 a night. So, you know, the city of New Orleans is definitely on the hook.
Could also be the battery pack itself. power radio. It's another little thing I learned. Y'all hear that? That's going to do it for the Lafayette Airmaster 10. I'm not going to bother with the power supply. Getting it worked on batteries, I think, was a lot better as far as portability of the radio goes, and it works pretty good. We didn't get into like replacing caps or anything like that. It's functioning pretty good. Just after replacing the battery, going through and making sure that we aligned the radio, and then we were able to, after that, get some reception on our VHF band and our AM band. So it was pretty good all in all. If you enjoyed this video, let me know by leaving some comments down in the comment section. Give this video a thumbs up. If you're new to this channel, go ahead and subscribe. You're already here. I don't know why you wouldn't do that at this point if you've hung out this far. But anyways, thank you for watching this episode of Having Fun Repairs. Take care and goodbye.
Bark.